refresh here. We are. Okay. So welcome to the live stream. This is the week of February 8th, 2024. So if you're watching this in the future, hello from the past. Hopefully the content that you're watching this for is still relevant. Otherwise, you probably wouldn't be watching it that far into the future. But I titled this one the Google Earth live stream because, as I mentioned in the classes probably the day before to my students, that I had run into a lot of questions about Google Earth. And so I wanted to just take this time to sort of address some of those questions and also to sort of give everyone a primer on how to use Google Earth. I'm sure there's lots of other YouTube tutorial videos out there explaining Google Earth, but I wanted to give my perspective since it's being used in my classes. So before I get into Google Earth, I guess I want to start with like a pedagogical perspective of why I'm using Google Earth in my classes. And it really breaks down into three main sort of reasons or goals. The first reason is that Google Earth is open access and it's free, so it's a tool that we can all utilize. I know I worked for companies that would use Google Earth all the time because you're able to do a lot of pretty cool things with Google Earth without having to pay for it, which is pretty great. And then another aspect is that because it's open access, there's a huge support community both from Google itself, but then also through YouTube videos and tutorials, forums, web pages, yada yada yada, so on and so forth. So there's a big support community, so you can simply search for help and support when you need help and support in Google Earth. And then the other main reason is also pedagogical, sort of meaning teacher philosophy. When I say pedagogical, I'm not trying to be big and jargony. It's just the simple way of saying teaching philosophy in a nutshell, at least how I commonly use it, is it provides scaffolding from which you can build on. Basically, if you're going to go on and be a cartographer, work in geographic information systems, GIS, Google Earth is a great starting point. Also, if you're not great with reading maps or you're not great with spatial awareness and spatial analysis, Google Earth provides a great sort of introduction and pathway beyond using Google Maps, like for driving directions, starting to understand how we can use spatial analysis in a tool like Google Earth to better understand how we relate to other places on the globe, how humans interact with one another, all sorts of analyses that you can do with Google Earth, and then springboard that into more complicated and advanced statistical and spatial analysis. So those are the reasons why I use Google Earth. And it's also because I guess there's a fourth reason. In an online class, you could very easily just use hand-drawn maps, right? Or we could in class walk through using a topographic map, and then I just point to a spot on the map, and then you have to tell me something about it, or I ask you to find something on a map and then you can point to it. Can't really do that in an online class setting. So this allows us to sort of provide the same content in a way that allows someone halfway around the world to also make a map without me needing to physically be present there. So those are the reasons why I use Google Earth. But let's get into it. So in order to actually use Google Earth to its maximum potential, I know I'm staying on the screen very long, but I'll get to it in a moment. We will need a few things. First, we will need a mouse. So if you see me in the bottom left of your screen, you'll need a mouse. You'll need a keyboard, and you'll need a laptop or a desktop computer. You can get away with this with a tablet that has a keyboard and a mouse that you can plug into it. So really the processing power is not the part I'm concerned with. It's the ability to use a keyboard and the ability to use a mouse. So if you're using a trackpad, it's going to be a nightmare to use Google Earth. If you're using a tablet, I mean, I have not tried to use Google Earth with a tablet. Maybe you're, excelling with Google Earth with just, your index fingers. But for most people, keyboard and mouse is what you're going to need. So first thing you're going to need to do is download it. Most of you probably have already downloaded Google Earth, but if you haven't, I'm just going to walk you through it here. So there's Google Earth on web. We don't want Google Earth on web. Google Earth on web is a very limited version of Google Earth. It has some features built in, but you have to have an internet connection to use it. It's also just a slightly different interface, so anything that I talk about is going to be talking about it in the desktop app. There's also a mobile version, again, because we want keyboard and mouse. We want to stay away from the mobile version. And then there's desktop. So if we go down to desktop, this is all the bells and whistles that you can get with Google Earth. There are a few things that are only supported in the desktop version that aren't supported in the mobile or the web version. And the one that's most important here that you can sort of see in the little thumbnail that they've created for us is the historic aerial imagery. I use that all the time when I'm using Google Earth in archaeology and anthropology, and we use it all the time in our classes. So being able to use historic aerial imagery, super useful, super important to instruction and also research, so we want that tool. So you can see a little image of it here in this thumbnail, and that's only available in Google Earth Pro. Now it's called Pro to make it sound like it's professional and you have to pay for it, but it's actually free. It's just a desktop app that lives on your device. So make sure you download it for the proper operating system. So if you're using a PC, you want it for Windows. If you're using a Mac, you want it for Apple. If you're running a computer that runs on Linux, make sure you're using Linux, although that's a very, very small proportion of you out there, but I always have to, shout out to the Linux users. And they even say as much right here, available on PC, Mac, or Linux. And then you'll notice they also mention here GIS data. So like I said, one of the nice things about Google Earth is that it's sort of this go-between. So there are whole departments at a lot of companies, city governments, anywhere you work with sort of maps and map making, whether that's civil engineering or you're working in a city government and you have to do tax maps, or you look at plat maps for real estate development. Any kind of career field where you're working in maps, it's probably useful to get a foot in the door with Google Earth, and you'll probably be working closely with someone who has a degree or expertise in geographic information systems. That's what this little GIS stands for. Technically speaking, Google Earth is a type of geographic information system. It's just a lot more user-friendly and free. It just doesn't have all the same bells and whistles, meaning all the features that a more advanced tool that might cost money for a subscription, or you might need to learn how to code, like using Python. We don't need any of that for Google Earth. It's free, comes with a lot of tools, still needs some explanation though. So I assume you've downloaded it and you launch it, and here we are in Google Earth Pro. So Google Earth Pro, you get to see the entirety of the globe. You can kind of, with your mouse, again, this is why a mouse and keyboard is so useful, because I'm able to spin the globe very easily. I don't want to be in the middle of the Pacific Ocean. A few hotkeys that I use on a regular basis. So obviously this tutorial is very much like a snapshot of what Professor Eric Olson uses. Oh yeah, sorry, I guess I didn't introduce myself, but I'm assuming that the people that are watching this live stream already know who I am. But in case you didn't know, I'm Professor Eric Olson. I teach anthropology classes at Cuyahoga Community College, Tri-C for short. That's the intro. There you go. But like I said, you're basically getting a snapshot of how I use this tool, and it's mostly how I use it as an archaeological tool and also an anthropological tool. You'll find I use the terms interchangeably. In the U.S., archaeology is a subdiscipline of anthropology. We all live under the same umbrella. Anthropology includes cultural anthropology, archaeology, linguistics, and biological or physical anthropology. So if you're taking my human evolution class, that's biological anthropology. If you're taking my archaeology class, that's archaeology. If you're taking my cultural anthropology class, that's cultural anthropology. Unfortunately, most schools, ironically, even though they have 4 subfields, linguistics oftentimes doesn't live in an anthropology department. It actually lives in like an English or a modern languages department. But anyway, I digress. So one of the things that I use almost always in Google Earth is I hit the hotkey R, and what R does is it reorients myself to true north on the globe. So you notice I had like some tilt here. In the upper right here, we've got our north. So if I click on the north, it'll reorient me to north. But for some of us that have jitters because we've had too much coffee, or we just don't have the dexterity to click on this. I know I've many times struggled, especially if it's like really small, or you need to be able to click in a very small area. I mean, like this is a very small click box we've got right here to click that north arrow. So I find it often a lot easier when I'm in a location and I need to reorient to north, because oftentimes when you're making maps, you want it oriented to north for consistency's sake. Pressing R is a lot easier than going up here trying to hit that click box. And then also you have to use this to angle it. This is basically giving you different angles. So if you hold down, you can now now it's like we're on a spaceship or a plane flying over the Earth, right? So this isn't very helpful if we want to get a plan view, which is basically a perpendicular to the surface. So if we hit R, it'll reorient us. So let's just zoom in here. Now when you're opening files in Google Earth, another thing that you'll need to know is how to import stuff. So anything that shows up as a KMZ file is going to be a Google Earth file. That's .kmz, although you can also get .kml. And you can import them using the import button over here to import a KMZ file. But oftentimes, if you've already installed Google Earth on your device, it'll usually automatically recognize that KMZ is a Google Earth file, and it'll show you a little icon of Google Earth, which is this little like gray marble looking thing. That's the Google Earth logo. Sort of like if you have a PDF, your computer will default show you the symbol of the app that is used to open that PDF. So if you're an Adobe user, it'll show you the Adobe Acrobat logo, indicating that if you double click on this, it'll automatically open in Adobe Acrobat. Just a little, I guess, tidbit of information if you weren't already aware of that. So you can either import, or you can just double click it and it should automatically launch in Google Earth. If you're running into problems, make sure that one, you have the correct version downloaded. So don't try to use the Apple version of Google Earth on a PC. If you're using the web browser version, and you'll know it's the web browser version because you need to have at the bottom here, you need to have it on your desktop or your little dashboard down here. And then those are the two basic ways that you would want to import it. Make sure that the app is open and that you either double click it to launch it, and make sure you save it in a location that you're going to remember. Don't just store it in your downloads file. Move it to a folder, like maybe give a name to your class that you're working on it in. Just put it somewhere that's consistent, because sometimes Google Earth files don't like to open if you've edited them and then you move them. And this is definitely true in other softwares. If you were to save this information and then move it and then try to reopen it, sometimes that information can get lost because you've moved it and it's looking, sorry for moving my mic, and it's looking for that data in a folder that it no longer exists in. So just some basic housekeeping stuff to keep in mind. So we're just going to use these examples from my archaeology class, and we'll assume that you've imported data. And you'll notice here that when it imports it, sometimes it'll put it in temporary places down here, so always check temporary places. This area called places over here, and most other GIS software, we would call that layers. And when you're working in lots of different types of GISs, you're going to have toggleable layers. So when I don't have them highlighted is when I don't have them checked. So if I check the box for archaeology reports, and if I expand it out like this, notice I have this little arrow icon that changes with my mouse. I can expand this out to make it bigger or smaller so that I can read more of it. If I don't have it highlighted, I won't be able to see it. Now, we're so zoomed out that we can't see any of these polygons anyway, so let's start zooming in. And if we want to zoom into one in particular, we can just double click it, and then Google Earth will zoom to it for us. And here's our polygon. And we call all these polygons because they're just shapes that have been created. And for this particular KMZ file, we have, sorry, I was just checking my chat there. You can probably see me hover over it. And also, just as a side note, I have now, I sort of have a dual monitor system set up here. I've got my cell phone with YouTube pulled up so I can see what the stream looks like as I'm doing it. Obviously, it's on a delay, but tricks of the trade. So this is our polygon for this particular project. Now, if we want to edit this polygon, what we can do is we can right-click. Now, I'm obviously giving you a PC version. If you're using Mac, there should be some equivalent of a right-click. You might just have to hold the click down. You want to get this drop-down screen, and there's a bunch of different options that we can use here. So we can save this as a new place. If you want to save this individual polygon in a separate location. So for my classes, you're only working on one site for the entire semester. You don't need all these sites. These are just all of the sites available. And you want to save yours in a separate location, you can. And then you'll basically have created a new KMZ file, and it's just for that polygon. You can email it to yourself, get a snapshot view, all this other stuff. If we go to properties though, it'll open up this editing window. So it's edit polygon. So we know it's a polygon, and each of these little dots here is what we would call a vertice, or these are the vertices. Each individual one is a vertex point. Basically, if I hold down left click and I move it, I am now changing the dimensions of the polygon, right? Now if I left click, or actually, sorry, right click without holding it down, I have now created a new vertex point. So if I wanted to extend it, I could do that. If I want to get rid of the vertex points, I could right click, and now they disappear. And so I have reconstituted this polygon. And then I can also change the color and whatnot. So I could change the width of the lines. I could change the color of the lines here. I can change filled and outlined. I could just make it outlined. So when I do that, you can see that little light red shading. I can also change the opacity. So if I want it 100% shaded, filled and outlined, now it's 100% red, right? And so it's only showing me Blakely Road here because it's overlaying on top of the polygon. But if I do 50%, I can now see sort of the trees and the shrubbery beside it. And then I can also go to view. I never use views, so I'm not really worried about view right now. This would be more like if you've ever seen someone using Google Earth to make a video where they're like flying to a different location to make it feel more cinematic, you could use view. Altitude, if you're trying to calculate altitude, this is beyond our scope because that would also require us to have some basic knowledge of the location in terms of its altitude, which would require additional information elsewhere. And then measurements. So this is telling me something about the polygon. So the perimeter is 0.998 miles. So we have, if you were to walk a circuit around from this corner all the way around to it, again, it would be almost a mile. Area, we can calculate the acreage. So it's about 4.61 acres. You can obviously calculate how many square meters it is. This is super handy, really useful for archaeology because we need to calculate I did it again, I poked the mic. To calculate the square miles or acreage of a particular project area, so we can quantify just what the footprint of it is. And then you also notice that these are sort of, I provided when I created these KMZ files for my students, but little basic description. This is a hypothetical scenario here, gives you some suggestions for edits, well, not edits, but where to go for future research within our collections here at Tri-C. And then you can also add your own notes. So if I go back to property, and you can start typing in your own notes of like, if you want to keep track of just some general sources, or maybe you find some interesting sites, like websites, you can add the links in here just to sort of keep tabs on everything. You can add images, add links, add local images, so you can start to build a sort of little catch-all repository around this polygon. But the other thing that you probably need to back up and explain, I say you, I'm referring to myself there in that case, sheesh, is if we go up to tools here and then we go to options, this is super important that you should probably get this set up before doing anything else. I'm just sort of walking you through what happens when you open up a file. But let's say you open it up and you don't like the coordinate system that you're using, or you don't like the texture colors. This allows you to modify what things appear as in your different views. So texture colors in 3D view, anisotropic filtering, labels, icon size, graphics mode. Don't need to monkey around with those. Don't need to change those. Those are fine. Especially considering we don't really want 3D view on because it can kind of obscure the reality. It's just sort of, it visually looks more interesting, but from an analytical perspective, it actually doesn't help a whole lot because sometimes it'll cover up polygons, because what it'll do is this, if this were in 3D view, the trees might actually be taller than, because they're assuming that this polygon lives on the surface, so then the three-dimensional trees that it generates would then cover up the polygon and then we couldn't see it. So not super helpful from an analytical perspective. So the one that's most useful here is the showing the latitude and longitude, abbreviated lat long. And I use decimal degrees just because it's a lot easier to transfer between other internet sources. Not everyone uses these other options, Universal Transverse Mercator. If we were doing archaeology or anthropology, I would prefer to use UTMs, which is Universal Transverse Mercator. But I understand that this is not a GIS class. This is not a geography class, so let's just keep it simple to decimal degrees. Decimal degrees are also so much easier to type in. Degrees, minutes, seconds, it's a lot slower, especially if you're doing copy paste. Like if you're on a wiki page and it has latitude and longitude, oftentimes it'll have it either in degrees, minutes, seconds, and decimal degrees, and you can just highlight the whole decimal degree and then copy that into Google Earth to locate that place. It's just a lot easier from a navigation standpoint on the internet, right? And what's your units of measurements? I have mine in metric. I prefer to use metric. You can have terrain, elevation, exaggeration, use high quality terrain, use imagery, map size, small, large. You can play around with that stuff too, general. So I'd just take a moment to look at all this stuff. Navigation, fly to speed, don't really need fly to speed, don't really need touring. Memory size, again, this is more if you're really getting into the weeds of like doing a lot of heavy lifting. And for most people, we don't need most of these tools, but they're there. So the most important one is making sure that your units of measurement and your latitude and longitude are in the units that you want them in. So the other thing we want to look at is the base layers. So these places are layers that we would import, right? These are places that I have selected or I've searched for, because remember, this is Google Earth, so it works similar to Google Maps. I can type in any address I want or location, and it'll Google search it basically and try to locate it. So you can try and find places around the world just by typing in whatever you want, and Google Earth will try to give you a location on the world based on whatever you typed. So just make sure that it has potential to be a real place. And then layers are ones that come pre-built into Google Earth, and there's lots and lots and lots of cool tools that come pre-built into Google Earth. One of the reasons I love Google Earth is because of all these free tools. So we've got, oh, and I'm realizing here, I'm talking about free tools. Give me a second here. I need to move my head. Oh, you're seeing behind the screen there. You got to see my streaming software. Had to move my head there so you could see. Now I'm on the right side of the screen, and you can't see the info like imagery, date, lat long, elevation, eye altitude, all that kind of stuff. But we now have visibility on layers. So we've got primary database. So if I turn that off, you'll notice that the map itself gets kind of barren. So all I'm seeing is the red polygon. Here, let me hit R again so I'm reoriented. Got the red polygon, and I can see the roads, but because I've turned off all of the Google Earth like native layers that come pre-built with the app, I don't get the labels of the roads. I don't get place names. So let me turn that. Oh no, does it not want to work? Okay, there we go. Terrain, I don't want terrain. Let's turn on roads, photos, places, borders and labels. I don't want announcements. I don't need 3D buildings. Don't need clouds. What's really fun is under more, there should be an option. Oh no, is it not under more? Oh, did they remove it? Oh, you're finding out in real time here. No, it's under gallery. Okay. That's not intuitive. Well, anyway, so let's back up. Let's back up before I get too into the weeds here. So I'm looking at all these layers, all these different sets of data that they have. Borders and labels, if I click the caret here to drop it down, it's going to give me borders of things like counties, of state lines, of country borders, labels for things. So if I hover over, it'll show me show or hide roads, borders, and other items in the 3D viewer. Yes, same thing. Places. So these are things that are like if you were on Google Maps, they would show up. So A&K Carpet, I guess, is a place that's labeled on Google there. Big Toe Sewing. So if I turn places off, I don't get those. So useful to have if you need it. Photos, if there were any photos that the Google user uploaded, Google Maps photos, those would also be preloaded into here. So you're basically getting the crowdsourcing of Google built into the app, that you can just see where these photos were taken, and that's also super helpful as well. Another thing down here when I was in gallery, and this is another one I really love, is that they've gone to the effort of georeferencing historical maps. So georeferencing basically means we've got this nice pretty map here, but let's say I wanted to see a map from, oh, and here's a Google Earth photo. There we go. Google Earth and event halls right up here. Here's another Google Earth photo. if I wanted to see a map from the 1700s, but I wanted to compare it to aerial imagery, I'd have to what's known as georeference it. So I'd have to match up the locations on that map with real world locations on this 2023 aerial photo. So we already have some of them done. So if I turn this layer on, and there's a map finder one, let me zoom out here, see where the nearest historical map is. Yeah, so this one's really fun as well. It's the Rumsey Historical Maps. It's a online retailer seller of historical maps and reprints and whatnot, but they have georeferenced a lot of maps. So the U.S. 1883 or 1833, to overlay the map on Google Earth, click the map thumbnail. So if I click this, bada bing, bada boom. So that's pretty neat, right? So now it has added it into my places. And if I turn on properties and I go to style and color, oh no, can I not? Interesting. I guess I cannot have them transparent. Or maybe I can and I just don't know off the top of my head. But now I can see all these other layers, so the road map should still appear. If I go back to my location, we can potentially, and then of course we're zoomed in at such a fine scale that it doesn't really tell me anything to have this 1833 map on. Geo-rectify it, zoom out. Yeah, so it doesn't really have anything on this map from 1833 that's going to be super informative. But you never know. It is very artistic though, because I think they've got an eagle made out of it. Yeah, there you go. This is an eagle head. Interesting. United States 1833. They have another Chicago 1857. North America 1786. So we could throw that on here as well. Back to Google Earth. There we go. So here's a georeferenced map of 1786 North America. And so that's another fun thing that you can do with Google Earth that I really enjoy using for historical imagery. And then under more, you can if there's a wiki page about a geographic location, you can just have the wiki page there. So there's a whole wiki on Ohio that you can click on. You know, if there's a wiki for particular locations as you zoom in, that might give you some context about a region or an area. Super helpful and informative about parks, U.S. Fish and Wildlife. What else we got here? Water body outlines, that's also helpful. U.S. government, city boundaries, U.S. school districts, if you wanted those as well. But the more layers you turn on, the more complicated it takes to load. So there's all the sorts of layers that you can have to get more information. So you can see water bodies here, the Ohio River, Allegheny, Monongahela, they're highlighted as well. I wouldn't always assume that if Google Earth has a water body highlighted that's the only water body. Sometimes it's based on government allocation of funds. You know, someone has to draw these borders in, someone has to create these polygons, and sometimes there's just not enough resources to draw every last stream and river. So, you know, they have the Allegheny drawn in here, and even then it's not perfectly drawn. But there's oftentimes, like, this is a little creek right here. This is not drawn in, but it is a water body. And we can see that sort of just intuitively. Here's where it feeds into the Allegheny, and yet it does not have, it's labeled here, Crooked Creek, but it does not have a water body boundary. So that's the other thing to keep in mind, is that the data is, you know, sometimes crowdsourced, just like with Wikipedia. We have no way of verifying or knowing where the info comes from. We want to double check that information ourselves with our own eyes, or trying to find the source material. So don't always assume that if it's not labeled, it doesn't exist. That sometimes does happen. So let's go back to our example here of Blakely Road. Let's say we're doing research and we want to make a new polygon, or we want to make a new pushpin, or we want to locate, I don't know, we want to know the exact coordinates of this intersection of Old Route 56 and Blakely Road. Let's go ahead and do the pushpin, so place mark. We've got all these tools up here that I have yet to talk about. So we add place mark, put that here. we can change the push pin. It always defaults to this ugly yellow one. I don't like it. I prefer something like this, this icon. And then we can relabel it intersection of 56 and Blakely Road. And then you'll notice, because remember in my options I changed the latitude and longitude to decimal degrees, I now have my decimal degrees here, so I can quickly copy that. So if I'm on a PC, I can do Control C to copy that, and then Control V to paste. And so these are my coordinates. So if I just want to find coordinates, I can just put a push pin there. I can also, if I just want to know the coordinates, notice every time I move my mouse, actually you probably can't notice because my head is in the way, so I'm actually going to move my head over here. Everywhere I move my mouse, it is changing latitude and longitude. So if I just hold my mouse there, the problem with that is then I have to keep my mouse there, and then I have to, probably using a pencil and paper, write down those coordinates, which is why I find it much more simple much simpler. Sorry for the grammatical error there, but it's simpler to just put a push pin and then get your coordinates that way. You don't have to save this. You can just close out of it. It disappears. If you want to save it, you would click OK. It would go here. Technically speaking, it is not saved. So if I were to close out of Google Earth, it would ask me to save my places. So this is a good opportunity for us to talk about saving that place mark. If I want to edit it, I would go here. Again, drag and drop, holding down left click, put it here. Change it, intersection. And then I could right click on it, and then I can go to Save Place As. And then that's going to pull up my computer, and then it's going to ask me where I want to save it. See, here's KMZ or KML. Doesn't matter which file you save it under, or whichever file type. So that's how you want to do saving, Save Place As. You can email it to yourself, you can get directions, all sorts of other fun things. But make sure you save it. You can also go up here and under Save, Save Place As, or Save My Places. Save My Places is just going to save whatever Google Earth file already exists. It's going to save it to there. If you save Place As, you can save whatever is selected. So right now it's just going to save this intersection. But if I go all the way up here and I click here on Archaeology Reports, it is now going to save all of the items in this folder. So that includes all, 15 or 16 sites plus my intersection. So if I'm working on a project and I want it all to live in the same file, so that if I were to say share it with my professor or a fellow student, because I have a push pin here, and let's say I want to put a new polygon in, or let's put another push pin in over here because this house turns out to be historic home number, 1, and we save that, and that's down here. So now if I want this polygon and these 2 points to be saved together, so long as they're in the same folder and I select that folder and then I right click and I say Save Place, now if I were to share that KMZ file, it's going to open this polygon, these 2 points, and all of these polygons. Right? So that's kind of the nice thing, is I can make it very easy to share sort of spatial information without having to have very sophisticated knowledge of GIS. Let's say I want to add a polygon now. So I want to highlight that this is a historic home, but what if I want to make it clear where the boundaries of that property are? So maybe specifying that the historic home is actually just this area around, and actually you can see a pool. Let's go to create a polygon, which is the Add Polygon tool. So we can pull that up here, and then if we right click to make each of these vertex points, and you'll notice it's flip-flopping because it's flipping about on the origin point. Now the blue one indicates where the last point is, so if I click here, it's going, I think it's going clockwise, yeah. Clockwise from whatever this point is. So the next one is going to go between the blue point and the next available red point. Whereas if I clicked back here, it's going to add it here. If I click here, it's going to add it there. If I click up here in this corner, it's going to add it there. And then I can drag and drop these points as I need. And if I want to get rid of them, right click to get rid of them. You'll notice it just defaults to this ugly white blob, so we probably want to change that. We want to just do, let's do outlined, and then the color of that line, let's just make it, I don't know, we already have red, so I mean I guess white's fine. Let's make it a little bit larger, so give it 4 points, and then click OK. Didn't name it, so I need to go back into properties and rename it. Historic home number 1 parcel or lot, whatever we want to call it. So now we can visualize it this way. So now we got a project area and an intersection, a historic home, and the extent of it. So obviously from a project manager perspective, you can say, oh, well, it looks like this historic home runs into these project boundaries. So that's useful if I'm a city planner or I'm a project reviewer and I need to know where these things are in relation to one another. And then again, if you save it all in the same folder, save as, then you can share that with anyone you want in an email because KMZ files are not that large. And now they can open it in Google Earth and very quickly see what you're talking about instead of having to, do a screenshot clip or what have you. And you can also, again, one of the reasons why people love using Google Earth in project management is I can also tell you the size of that lot. So it's 1.12 acres. So useful if I'm a project manager and I'm sending someone out into the field and I'm saying, hey, look, you got to survey 1.12 acres to make sure that this historic home is not going to be adversely affected by this road widening project here. Pun intended, this is where the rubber meets the road of a lot of historic preservation, archaeology, and where Google Earth kind of fits into all of that. Another thing that we might want to do using Google Earth, I don't usually use these tools. You can use a path if you're trying to calculate like the length of the road. So if you wanted to know how long, so we have the polygon, but that doesn't tell me how much road length there is. So if I click here and I just follow this road, I'm going to run into a problem here where I reach the end of where I can see. So what I'll have to do in this case, I'm sure someone could show me another tool to do this better, but I click OK, and then I have to scroll down and then continue editing by going back into properties and then make sure I click this to make sure it's blue and then keep going to finish my path. Then I have to go to measurements. We have 0.47 miles. That's how much road we're dealing with. So almost a half mile of road, which is a different way of measuring it. You could also, if you wanted to know the distance between here and somewhere else, like let's say you wanted to walk from this historic home to Dixon Meats, and you wanted to calculate what the straight path distance is, like just from here to there, you could calculate a path that way. You can also do this if you don't need to save that path. You can do that with the ruler tool. So if I pull up the ruler, I can just left click here and then hold it to wherever I want to go, and it shows me the map length. I can change it to whatever I want, miles, yards, feet, etc. Ground length. What's really cool about this is if I go to path, it's the same tool. If I go into ruler and I go to path, this part is one I love. Show elevation profile, and then from the depths it'll show you the elevation changes on the path that you just drew, and it'll give you this big old arrow showing you okay, here's where you're starting, then you're going downhill and then uphill, and it gives you the actual elevation readout. So this is a profile view of that linear path that we have right here, and what the elevation is and how far you've traveled, and also the elevation changes in meters. And again, because my settings are in meters, so that's what it's going to show me is my elevation in meters. It's going to tell me my range totals, elevation gain loss, max slope. So obviously if I was a civil engineer and I needed to figure out a road like really quickly, like I'm just working on a project, someone tells me, hey, we're going to be fixing Blakely Road, I can use Google Earth for that. But let's say I'm an archaeologist and I'm not an engineer and I need to quickly communicate with an engineer. This allows me to better understand what the engineer's needs are by using this elevation tool. I love this elevation tool. It's really cool. It's really neat. You can just sort of hover over it and if you're cycling somewhere, it tells you where the hills are. So that's another tool you can use as well. Let's, reorient ourselves here. You can change the daylight if you wanted to. I don't usually do that. You can look at Google Earth, sky, Mars, moon. I've never played around with that stuff because I'm obviously, as an anthropologist, I'm focused on where humans are. Although we have been to the moon and been to Mars, humans have only set foot on the moon, and even so very limitedly. But that's getting tangentially far afield. But the other tool that you'll probably want to use is historic imagery. So when we click on it, it shows us here all the different aerial photos that we can go back in time to. So most of the cases in the US, it'll say 1985, and it's really grainy because the photos are 40 years old, but they're also oftentimes from a different scale. So like if the plane was flying above the Earth, or the satellite was, had a different type of lens, it's not meant to be very detailed. So if I zoom really far in, it doesn't tell me a whole lot. Now if I go to the present and then I compare that, so this is 2019, and I compare that to 1985, I can still kind of make out some similarities, like the road is still there. Now let's turn off some of these layers so then I can actually compare. So yeah, you can tell there's a road there. It's just really grainy. You can tell that this field has been a field for a long time because it still shows up, but there's not much else I could say, right? 1993 looks like this is as far as the 1993 aerials go. See what the next available aerial is. Ooh, wait, hang on. Let's turn that off, go back. Yeah, 1983, they only have aerials up to this line here. That's why it looks like the 85 one over here, and you don't see the 85 one over here. So I don't have the detailed aerial photos so I only have aerial photos back to 93 that are detailed. And I can see, here's that home, and pretty much in the same location. And I go through time, and I can look at the changes. This one's really detailed and really helpful. Notice it's in black and white. So we're able to see more details as we go through time. 2003. So this is a really handy tool as well, looking at different land use changes through time. Now let's say I want to save this map because I want to use it in a paper I'm writing. So I could either print it. That's going to give you a PDF version. We probably don't want that. Or I can save the image. Now if I click save the image, I'm going to get a couple of tools that come up here. It's going to give me a legend, untitled map. In the bottom right, it's going to show me the scale, a north arrow. It's going to tell me to activate Windows. Yes, I know. That's on my computer. It's not actually in Google Earth. I can edit them, so I can say example map. Then I can write a description, or I can just delete that. And then if I go to more options, and then I have legend, so if I toggle these on and off, they'll disappear. So if I get rid of scale, the scale disappears. Compass, that's the north arrow. Probably don't need a legend. Maybe I want a legend. Historic home, number 1 parcel, untitled path. So it's showing me all these different things that are appearing inside of the map, boundaries that are visible, right? And then it says styling. Do I want a grayscale? Do I want a full color base map? Then I wouldn't really worry about resolution too much. This is more for like publication quality. So I would just leave it as current, and then if you click save image, it'll prompt you to save it somewhere, and you can save it as a JPEG or a PNG. And then you have a image and you have a map. So that's kind of neat as well. And those are the basic tools. I think I've gone over just about everything that is most relevant for Google Earth. I'm going to go ahead and delete these because I don't need them. They're just for example purposes. Remember to always save your projects. And that's probably, I'm just trying to think, is there anything else? I don't think so. So if you're still having trouble with Google Earth, feel free to reach out to me in the usual channels if you're a student of mine, whether that's email, remind.com, or if you really want to, you could reach out to the tricanthropology@gmail.com, which is for questions for this live stream. For next week's live stream, I've got a few questions banked already from students, so we've already got a few building up there, but if you have questions, get them into me ideally 24 hours in advance, so like preferably by like Wednesday afternoon, so that I can actually prepare for them. I find it very hard to answer questions on the fly in the live stream chat, so it's not that I can't do it, it's just, questions get answered in the order in which they're received. So that's going to do it for this live stream. Hopefully that was helpful for you. And until then, make sure you're reading. It's always good to read. And whether it's stuff for my class or not, I will always encourage reading. And I will talk to you all soon. And with that, I bid you all adieu.